Class example 3.16 is a bit of an anomaly in this chapter. The reason for this is we'll solve an equation where the variable is in the base. That means it is not an exponential equation. An exponential equation has the variable in the exponent. As we saw in earlier examples, we solve exponential equations by writing common bases, or as we'll see later, by using logarithms. In this case, we'll take a different approach, where we will first isolate the power term, and then we'll try to modify the power term with a new exponent so that we can eventually end up with an exponent of 1. Because the second part of our solution will have us raising both sides to a certain power, in the end it'll be -4/3, it will complicate things if we leave the 2 out front. So our first step is to divide both sides by 2. This gives us 3x minus 1 to the power of -3/4 equal to 8. Well, in the end, we want to have something that says x equals, which means we're going to need to isolate that x inside the bracket. But we can't do that until we have the bracket to the power of 1. So we ask ourselves, what would we multiply -3/4 by in order to generate 1? And the answer is, it's reciprocal. Notice we didn't change the sign. We multiply a negative by a negative to achieve a positive. So, multiplying the -3/4 by -4/3 actually means that we're raising each side to the power of -4/3. The result will be that on the left side, these two exponents cancel out and generate a 1, and on the right side, we can evaluate 8 to the power of -4/3. Here we see that 8 to the -4/3 is 1/16. If you want to do this step by step, you could think the cube root of 8 is 2. 2 to the power of 4 is 16. 16 to the -1 is 1/16. Then we add 1 to each side, which is like adding 16/16. And then dividing by 3 is like multiplying the denominator by 3. We get a result of 17/48. We can check this by putting into our calculator the left side of the equation, subtract the right side of the equation, and then pressing second, calculate 0. Alternatively, we can graph y2 as being 0 and type second calc intersect. Where the two lines intersect, the x value determines our solution. We see here 0.354167, which is equivalent to 17/48.